Alrighty, so today we're still talking about factoring. Okay, we are going to review factoring by grouping, where we were splitting it into two groups and then factoring using the greatest common factor. And then today we are going to introduce special cases. Okay, the main one we are going to introduce today is called difference of squares. So sorry that's so shaky. See if I can make that a little better. Okay, so the first one, difference of squares. But before we get into that, let's go ahead and review. Okay, so our first two questions, we are factoring out the common factor of each expression. Our first couple are binomials, meaning we have two terms here. Okay, well, our first rule is if the first term has that negative, if it's our leading coefficient is negative, we're just going to factor out the negative, take it out. Okay, well now I look at 12 and 6. And you could make a list, right? I could make my little factor list for 12 and 6, but I know that I can actually divide 12 by 6, our smaller coefficient. So that means that our greatest common factor is 6. Okay, now I look at my variables. I have b to the 7th and b squared. Okay, all I have to do is take the smaller amount, which is b squared. And now I figure out what's left inside when I divide out my greatest common factor. Okay, so I'm going to take each term and divide by negative 6b squared. Well, I know that negative 12 divided by negative 6 is going to give me positive 2. If I had 7 b's being multiplied, but then I divided 2 away, that's going to leave me with 5 b's being multiplied, or b to the 5th. Okay, now I take positive 6 divided by a negative 6. That's going to give me a negative 1. And then 2b squared, or 2b's being multiplied, and then dividing all of those 2b's. I'm not left with any b's on that coefficient, so we are done. There's my factored expression. Okay, let's do the same thing for number 2. Still a binomial, two terms. My leading coefficient is negative, so I'm going to factor out that negative. Okay, well now I'm looking at 20 and 25, okay, and my smaller one cannot go into my larger one, so I'm just going to go ahead, just for review's sake, make a couple factor lists for these guys. So 20 is going to be 1, 20, 2 times 10, 4 times 5. 25 is 1 and 25. And 5, and 5. Okay, so I can see that my largest number, my greatest common factor, is 5. Okay, now I look at my variables. My first term has a b. My second term does not, so I cannot take any b's. The only thing I can factor out from both of those terms is that negative 5. Okay, so now I have to do is figure out what's left inside. I take each one of my terms, divide by my greatest common factor, which is just negative 5. Negative 20 divided by negative 5 is going to give me a positive 4, and then with that b still attached. Positive 25 divided by negative 5 is negative 5. And we're done. We factored out our greatest common factor in front, and what was left inside when we divided it out. Okay, so now let's review factoring using greatest common factor, but this time I have 3 terms, okay? So I'm dealing with 3 different coefficients here, 90, 63, 72. So I'm actually going to make factor lists for all 3 of these numbers. Okay, and yeah, this takes some time, but it really shows you the greatest common factor, the biggest number that both of these can be, or all of these can be divided by. And maybe you can estimate it off the top of your head. Okay, so 90, 1, 90, 2, 45, 3 times 30. 4 doesn't go into it, 5, let's see, 90 divided by 5 is 18. I don't think 6 does. 6, 15, 7, no, 8 doesn't, 9 does, and 9 and 10. Okay, so we're good for 90, 63, 1 times 63, 3 times, let's see, 21. 4 doesn't, 5 doesn't, 6 doesn't, 7, I believe is 9. Let's double check. Yep. And we're good for 63. Okay, now 72, 1 times 72, 2, 72 divided by 2 is 36. 72 divided by 3 is 24, so 3 and 24. 72 divided by 4 is 18. Didn't know 4 went into it. Okay, 5 doesn't go into it. 72 divided by 6 is 12. And 7 doesn't go into it. 72 divided by 8 is 9. Okay, lots of ones for those. So now, out of all three of those lists, what is my biggest number that appears on both of those lists? Let's see. And I believe it's 9 out of all those lists. Okay, so we can factor out a 9. Not a negative 9. My leading coefficient is not negative. Okay, now I just look at my variables. I have 3 here, 2 here, 1 here. Take the smallest amount. That's 1. Factor it out. Okay, now I'm going to leave myself some space because I need to take all 3 of my terms and divide it by my greatest common factor. So 90 divided by 9k is going to give me 10. 3k's taking 1 away will leave me with 2. Same thing here, divided by 9k. 63 divided by 9 is 7. Yes, that was correct. Yes. And then I had 2k's, but I divided 1 out, so I'm left with 1. 72 divided by 9k was 8, positive 8, and no k's left on that one. And we're done. Beautiful. Okay, so number 4. Again, I'm dealing with 3 different coefficients here. I'm dealing with 100, 40, and 70. Now, I am going to kind of do a little bit of a guesstimate because I can see that each one of my coefficients ends in 0. So, the number I know I could divide all 3 of these guys by is 10. So I'm going to factor out a 10. Without even making my list, I'm just going to factor out that 10. Okay, now I'm going to look at my variables. I have 2 here, 3k's, and then 5k's. Take your smallest amount, so k squared. And now I'm going to figure out what's left inside. Okay, so 100 divided by 10 is going to give me 10. If I had 2k's, but then I divided all of them out, no k's left on that guy. Negative 40 divided by 10 is going to give me negative 4. And then if I had 3k's, but I divided 2 out, I'm left with 1k. Negative 70 divided by 10 is going to give me negative 7. And then if I have 5k's and I divided 2 of them out, I'm left with k cubed. Sorry, that's super small. Okay, now, if 10 were not my greatest coefficient after just guessing, then all 3 of these guys I could take something away. But notice 10, 4, and 7, there's no number I can divide all the 3 of those guys by other than 1, so we are done. Beautiful. Okay, now for numbers 5 and 6, we have 4 terms, and all 4 of these terms don't have something in common. So this is where we have to factor by grouping. I'm so sorry, that's so shaky. Factor by grouping. For just numbers 5 and 6. We'll get to our special cases here in a second. Okay, so remember, factoring by grouping is where you're just going to split it into groups. Okay, so I'm going to take my first 2 terms and my second 2 terms. And I'm just going to focus on one group at a time. So out of my first 2 terms, well, I know that I can divide 36 by 6, that smaller coefficient, so I know automatically I can take out a 6 out of 6 and 36. Okay, now I look at my variables. If I have 3 a's here and 2 there, I'm going to take my smaller amount, which is a squared. And now I figure out what's left inside from just those first 2. So 6 divided by the 6 just gives me 1. A cubed, or 3a's being multiplied, dividing 2 away is going to leave me with just 1a. And yes, you could put that coefficient of 1, but you don't have to. Okay, well now I have negative 36 divided by 6 gives me negative 6. I had 2a's, I divided all 2 of them away, so nothing left. Okay, so that's factoring just the first 2. Now let's focus on my next 2. Okay, well the first thing I see is that the first one is negative, so I'm going to take out that negative. Okay, but now I see that between just 1a and 6, there's nothing in common. So I'm going to go ahead and write negative 1 because that technically is negative 1. Now we figure out what's left inside. Okay, well when we divide out that negative, negative divided by a negative just gives me a positive, so that's going to make that positive a. But now I'm taking positive 6 divided by negative 1. Well, that now leaves me with negative 6. Okay, and now here's what we notice, and here's our goal when factoring by grouping. 2 of these pieces are exactly the same, a minus 6 and a minus 6. They become one of our factors. The other factor is what's left on the outside. 6a squared minus 1. And there we go. We're done. Beautiful. Okay, now let's look at number 6. Same thing, 4 terms. All 4 terms don't have something in common, so let's go ahead and look at the first 2 and then the last 2. Okay, so out of my first 2, between 2 and 3, there's no GCF besides 1. Okay, so I'm not even going to write the 1 because now I'm going to look at my variables. Okay, so if I have 3 m's here, 2 m's here, I'm going to factor out smaller amount. Oh no, I used a different color. That's okay. First one will be orange. Whatever. Okay, so now I take each one of my terms, divide it by my greatest common factor, which was just m squared. That's the only thing those 2 terms had in common. So 2 divided by 1 just leaves me with 2. But then 3 m's take away 2 m's leaves me with 1 m. Negative 3 divided by that invisible 1 leaves me with negative 3. 2 m's, taking away all 2 m's, and I'm done there. Okay, let's look at my next one. Between 10 and 15, I know that my GCF, the biggest number I could divide both of those guys by, is going to be 5. So I'm going to take out that positive 5. Okay, well my variables, this guy has an m, that guy doesn't, so I cannot take out any variables. So let's go ahead and figure out what's left. 10 divided by 5 leaves me with 2. And then that m still attached. Negative 15 divided by 5 leaves me with negative 3. And boom, my last group is factored. Okay, now we reached my goal where 1 or 2 of the pieces are exactly the same. They become one factor, 2m minus 3. My other factor is what's left on the outside. M squared plus 5. And there we go. Beautiful. Okay, now we get to our new cases. So this is where we are factoring what we call difference of squares. And the reason it's called difference of squares, we know that in math, whenever you see a subtraction sign, that means the answer is a difference, right? Difference means subtraction. Squares means you can take the square root of each of these terms. Okay, so here's what we have to do. We are going to take the square root of 16 and the square root of 9. Okay, well the square root of 16 is going to be 4. Square root of 9 is going to be 3. And we don't really care that it's a negative quite yet. And technically the square root of k squared is just 1k. So once we identify the square roots of each of our terms, then it actually becomes really easy to put it into factored form. Okay, so you're always going to give yourself your 2 factors. My first term is the square root of my first term. okay, and that's going to be 4, and then one of those k's, because the square root of 16k squared is 4k. So on each of your first terms, it becomes that square root. Okay, then for your your second term, it's going to be the square root of your second term. Okay, and let me just color it code. So we have, for the first spot was 4 and then k. Second term is going to be the square root of your second term, 3 and 3. All right, now, what you'll notice is that these guys only have 2 terms, whereas usually we see a middle term when it comes to a quadratic. Okay, well that middle term canceled itself out, and the way it did that is 1 is positive and 1 was negative. Okay, and here's what I'm gonna do. So this is our answer. This is factored form. Okay, pretty easy to find. You just find the square roots of your terms. Put 1 positive, 1 negative. But I'm actually going to multiply this out and show you guys what it would end up like, okay, to show you how that middle term cancels out. So 4k times 4k is 16k squared. 4k times a negative 3 would be negative 12k. Then I have 3 times 4k, that's positive 12k. And then 3 times negative 3 would be negative 9. Okay, well we can see that those middle 2 terms, negative 12 plus 12, they just turn to 0, just leaving me with 16k minus 9. And there we go. Okay, so that's why we only see 2 terms with a difference of squares, because those middle guys cancel each other out. Nice, so let's do the same thing. Okay, so we need to take the square roots of both of our terms. So the square root, and I'm just gonna write the x's with the 25, the square root of 25x squared, and then the square root of 4. Okay, well what is the square root of 25? That's gonna give me 5. And then the square root of x squared is just 1x. Square root of 4 is 2. Okay, well now it's pretty easy peasy once you identify the square roots of both of your terms. Okay, your first term in both of these pieces is going to be the square root of your first term, so 5x and 5x. Your second term in both of these pieces will be the square root of your second term given, and that's going to be 2 and 2. Okay, well we know that in order to have just 2 terms, one had to be positive, one had to be negative. And we're done. Easy peasy. Identify the square roots. Square root of the first term in front, square root of the second term second, one's positive, one's negative. Awesome, let's do it again. Okay, so this is a difference of squares where you need to find the square root of just k squared. Okay, well, again, the square root of just k squared is just gonna be 1k. And the square root of 4 we know is 2. Okay, well now I just give myself my 2 factors. First spot is going to be the square root of your first term, so that's k and k. Second spot is going to be the square root of your second term, 2 and 2. In order to only have 2 terms, they had to cancel each other out, making it plus and negative. And we're done. Awesome job. Okay, let's do it one more time. So I have 2 terms. This is a difference of squares, so I need to find the square root of 16b squared and the square root of 25. Okay, well, square root of 16 first is 4. Square root of b squared is just 1b. Square root of 25 is 5. Okay, give yourself your 2 factor pieces. First spot is the square root of your first term, so 4b, 4b. Second spot is the square root of your second term, 5 and 5. In order to only have 2 terms at the end, they had to cancel, so plus and negative. And there we go.